So we have seen that the circular matrix has eigenvectors in the form of this, and eigenvalue, we can just write DFT of x, eigenvalue as the DFT of x. And what is x? X is just a n element vector, which is the first column of the matrix, circular matrix C. So here, and this will be n minus 1 all the way to n, x of 1, this will be x0. Okay, now we can actually extend this equation and include all the eigenvectors in that equation and all the eigenvalues. So what I mean by that is that instead of an eigenvector, we can write this as an eigenmatrix, and we can also write the eigenvalues in a matrix form like this. Actually, this will be in the right hand side. So the form of W is like this. So there's Cx, which is just nothing but this. There will be a subscript x, and the columns of W are just W0, W1, and so on and so forth. Wn minus 1 here. Here, using the subscript m, I have to put a Wm. So here are the vectors, eigenvectors in the columns. Here again, it's W, it's just this matrix again, and the capital lambda, it actually contains the DFTs of x vector in its diagonal, and all of the rest of the non-diagonal elements are 0. So this will give us the same equation here, but here we are writing all of the eigenvectors and all of the eigenvalues all at once. Okay, now we can extend this equation here. First we have to look at some properties of W. What is W actually? W is, the first column is W0, second column is W1, third column is W2, last column, the nth column, is W of n minus 1. So what is W0? W0 is Wm at m equal to 0. What is Wm? Rho m square, rho m n minus 1. That's the form of Wm. So what is rho m? E to the power j to the power 2 pi n, rho m square, 2 pi j twice pi m n times 2 dot dot dot, so j twice pi m over n times n minus 1. So what if we make all of the m's here 0? That's what Wm. Then that's all just 1. So W0 is just all 1, n ones. What is W1? All of the m's just 1. What is W2? All of the m's just 2, and so on and so forth. So what will be the shape of W? The first column is all 1. The second column, that also starts with 1 because always does 1. So the first row is also 1. Here we have row 1 all the way to row 1 n minus 1. Here we have row m minus 1 all the way to row n minus 1 to the power n minus 1. So what if we take W conjugate? W conjugate is nothing but complex conjugate of W. So we take the complex conjugate of each of the members and we transpose that. So this is the complex conjugate, and this is the transpose sign. So if you you can verify that easily by yourself, that if we do that, these operation, all we're doing is just inverting the power of all of these elements. These are just 1 to the power minus 1 is just 1. So if we invert all of these elements, what we're doing here is that we are getting a matrix like this, because they are complex. Okay, and we know that rho m is equal to e to the power j twice pi m over n. If we want to take complex conjugate, that's just putting a minus, so we are just inverting the power. So minus 1 all the way to minus 1, here n minus 1 all the way to n minus 1 minus n minus 1. We just put, this is double conjugate, and we just put minus 1. We just inverted the power, because by taking complex conjugate we are just inverting the power here, because e to the power j twice by m over n is rho m. Now if we multiply double conjugate with any vector y, let's use y, what we are getting, we are actually getting, let's see what we are getting, minus 1 n minus 1, and this is rho n minus 1 inverse, and here n minus 1 minus n minus 1. And what is y? Y is this. So if we take any row here, any row, let's take the mth row. So this is the 0th row, this is the first row, second row, and this is the n minus 1th row. What is the mth row? The mth row, first we have y naught times 1, because all of the elements are 1. Then we have, for mth row, the second element will be y1 times rho m minus 1. The third element will be y2 times rho m minus 1. Oh, sorry, it will be minus 2. Okay, so I did a little mistake here. This will be rho 1 minus n minus 1. Here you go. Just the previous matrix was right, just did a little mistake here. Okay, so this is the mth row, so n minus 1 p here, and this is nothing but the DFT of y. So if we multiply doubly conjugate with y, any vector, this is just taking the DFT of y.